So this next video is looking at the various rules for exponents, and they're all listed out on page 88 in your textbook, so you may want to take a look at that as well. But once again, the examples that I'm going to use are on page 91. And I'm going to continue to split this video into a couple of different sections. And in this video, we'll take a look at the product of powers rule, and if there's time, we'll do the powers of powers rule. So the product of powers in your book looks like this: a to the m times a to the n, and the rule says if the bases are the same, so they're both a in this case, you can add the exponents together, a to the m plus n. And a real-life example of that would be 5 squared times 5 to the 7th. So our bases are the same, right? They're both 5. And to get the answer, we would just add the 2 and the 7, the powers together. So it would be 5 to the 2 plus 7, or 5 to the 9th. And the same is true if you have just a variable. So x cubed times x to the 5th. That's just x to the 3 plus 5, or x to the 8th. And all that kind of makes sense. Say I have y squared times y cubed. Well, y squared is really y times y, right? I've got two y's being multiplied together, and y cubed is just three y's. Y times y times y. So altogether I've got 1, 2, 3, 4, 5 y's. So when I'm multiplying them together, really I'm just counting up the number of y's I've got all together, or adding the exponents, 2 plus 3. So y squared times y cubed is y to the 5th power, and that's the answer. So that's the product of powers rule, where you're just adding the exponents. Make sure that the bases are the same. If I have an example where the bases aren't the same, say I have x cubed times y squared. I can't go xy to the 5th, right? Because x cubed is x times x times x, and y squared is y times y. There's not 5 of anything here. So in that case, because the bases are not the same, it just stays exactly how it is. So, oops, that should be a y squared. So bases must be the same. Must be same to add the exponents. So that's something really important to notice. Bases have to be the same. There's a variation of that, kind of a shortcut, called the power of powers rule. And in your book, it looks like this: a to the m in parentheses raised to the n. And that rule says if you're raising a power to another power, you can just multiply the powers together. A to the m times n. And what that would look like as an example would be this. What if we do 7 squared, and we'll raise that to the 10th power? Well, that answer would be 7 to the 2 times 10, or 7 to the 20th. And why that would work is really just a shortcut of the power of products rule. So say I was doing a slightly different, a smaller one, 7 squared, and I was cubing that. What that means is that I've got 7 squared times itself 3 times, right? 7 squared times 7 squared times 7 squared. That's 7 squared cubed. Well, now I could just think of this as using the last rule we talked about, where I could just add up the exponents, right? The bases are all the same. They're all 7s. So I've got 2 plus 2 plus 2, so 7, and 2 plus 2 plus 2, or 7 to the 6. But notice that's the same answer that I would get if I just multiplied those powers together. 7 to the 2 times 3 is also 7 to the 6th power. Sometimes that can get a little confusing. Am I supposed to multiply these exponents or add these exponents, especially if you're doing a whole bunch of these kinds of things? So what I do if I'm forgetting which, is to write out what they mean, just like I did here. Just write out what 7 squared cubed actually means. It means 7 squared times itself 3 in a row, and then I can usually figure out what the heck I'm being asked to do. So let's just do one example on page 91. Maybe we'll do number 12. That looks kind of nasty, right? We've got a negative exponent and we've got fractions involved, but you're going to see that it's really the same rule that we've been doing all along. I'm going to just get another piece of paper here, some of my magic paper. This is number 12 on page 91. Page 91. And I've got 2/3 raised to the negative 5th power. And I've got 2/3 raised to the power of 4. And I'm just going to go ahead and use the rule. If I've got bases the same, I can add the exponents together. So I've got bases the same, right? It's 2/3. All I need to do is to add the exponent. So I've got a negative 5 plus 4, which is going to be a negative 1. So 2/3 to the negative 1. And you'll see in a later video what we do with that negative exponent. But for right now, I'm just going to leave it as it is. Let's do another one where we've got something with parentheses. How about, let's do 6. So number 6 says 2 to the 4th squared. And I can think about that one of two ways. I can remember the shortcut rule, which just says to multiply the exponents and go 2 to the 4 times 2, or 2 to the 8th, right? 4 times 2 is 8. Or if I'm forgetting what that is, I can just write out what it means. 2 to the 4th times itself, 2 to the 4th. So I've got 4 2's here, 4 2's over here, which means I have 8 2's. 4 plus 4 is 8, or 8 2's all together. The instructions on 91 say to evaluate the expression and tell what properties of exponents you used. So if you checked an answer, neither one of these answers would be complete yet. They would want us to actually come up with a final answer. So you could put that into your calculator if you wanted to, but I'm going to leave it as is for right now, just to be able to keep track of what the answer or what the rules are. Let's jump down and take a look at some of the problems on 24 through 35 on that same page. It says simplifying algebraic expressions, tell which properties of exponents you used. And let's start off with, let's do number 27. It's an odd problem, but it's a pretty good one here with variables. So number 27 is w cubed times x to the negative 2 and w to the 6 times x to the negative 1. And I'm not going to worry about the negative exponent rules here. I'm just going to use the adding the exponent rules. Remember, to add exponents, I have to have the same bases. So here's one set of same bases, the w's. So that'll be w to the 3rd times w to the 6, which is w to the 3 plus 6. And then I've got some x's. So that'll be times x to the negative 2 plus a negative 1. Altogether, this is w to the 9th times x. Negative 2 plus negative 1 is negative 3 to the negative 3. And I'm going to leave that answer as is. There is one more thing we could do to get rid of that negative exponent, but we'll do that in another video. So this totally works. W to the 9th times x to the negative 3. All right, so that's it for those two rules. I'm in the next video, I'll take a look at the quotient of powers rule.